For this blog entry, we're going to focus on the GOES 1-minute imagery that was available on this particular day. This is from 21 May of 2014, and there was severe weather across Colorado and Wyoming. First, let's look at the RTMA focused in on the Denver area, which is right here, and we're looking at the surface dew points along with the surface winds. Notice the dew points were relatively high for this area in the low 50s, corresponds to the red here. And then west of that, you can see dew points that were much lower over higher elevations with a convergence line that was running roughly something like this west of Denver. Now here's the GOES 1-minute imagery that was available. During this time period, we had super rapid scan operations for research, which is SRSOR. Available to us, and that's important to note because that 1-minute imagery is available with only a few interruptions in there, as opposed to the SRSO imagery, which can have some more interruptions. So in other words, we had nearly continuous 1-minute imagery for this event here, so we could look at this in quite a bit of detail. Let's go ahead and zoom in first, and before the event, it's good to look at the pre-convective environment here. In other words, what air masses and boundaries do we see in the imagery that can be helpful for us. So we look at this particular region of Colorado and we see cumulus streets that are oriented parallel to the low-level flow. So they're approximately oriented like so here in Colorado. And that's an indicator of instability. We have an unstable air mass whenever you see this in the visible imagery here. Further north, I'll go ahead and circle this region up here in Wyoming. These are stable wave clouds. These indicate a stable air mass, and they're oriented like this approximately, and they tend to line up perpendicular to the flow at inversion top level. So we have a couple different air masses in place here. We do have additional heating which will take place, so this could change up here in Wyoming by the time we get later into the day. But in terms of where the active convection is at this particular time, it's over the higher terrain. Up here in Wyoming, over the Laramie Range, which is approximately right in here, you can see thunderstorms initiating in this region here along higher ridgetop levels where convective temperature is quite a bit lower. Similar story down here in Colorado, where you see quite a bit of convection developing here, again where convective temperatures are lower over higher elevations. And notice in the SRSO imagery you can see some of these updrafts in here begin to get going, and then they dissipate as they move to the northeast. The reason for that is they develop over these ridge tops, and then they move a little bit to the northeast. They still haven't hit that theta E axis yet in terms of the higher moisture, so they die. However, if you note this particular storm right here, it seems to have more persistence associated with it. It's a little bit further east, and what's happening is this particular storm, which is developing along these ridge tops, actually intersects that moist axis, and then it begins to grow, unlike these other storms which were dying further to the west here. Let's go ahead to our next time period here. So this is going to go from a little before 1 p.m. Mountain Time to a little bit after 2 p.m., about 2:11 Mountain Time, just to give you an idea of the times that we're looking at here. Let's go ahead and focus in on Colorado. And a couple things to note. Here's that thunderstorm. I'll call it a thunderstorm complex because it's actually a few different storms at this particular time coming off the higher terrain. But the signs you can look for here is that you have intensification taking place. You have a few different updraft locations. You have one right here, right over here, and it looks like the main one is right here. So you have a few different updrafts, and it's moving east towards this region where you see these unstable cloud streets here. So that's important to note. It looks like the southern end of the cloud streets kind of comes around like so here, and you see this clear region down here, probably associated with a drier air mass or just more subsidence for whatever reason, not as favorable an environment for thunderstorms. So if you look at some of these updrafts over here, they move into that drier air mass here, and they dissipate rather quickly. So the thunderstorms that would develop would be along and maybe north of that line that we just drew in right here, because we analyzed those low-level cloud streets indicating the more unstable air mass that's in place here. Other interesting thing to note is we begin to see this up here in Wyoming. You see the stable wave clouds to the north, and to the south of that you see unstable cloud streets. So we do see indications of that unstable air mass developing here in southeast Wyoming, kind of slowly moving towards the north. So another thing to look at with this storm down here in Colorado, go to the last frame, and you can see the approximate center of the storm is right here. If you look southwest of that, you see an area right here. And the reason I'm circling that is we want to note how that changes in appearance in the next time period here. So let's go to the next time period. I'll stop the loop. This is at 2030 UTC, which is 2:30 Mountain Time. And I'll go ahead and zoom in on the Denver storm, and you can see, first of all, a well-defined flanking line right here. Here's that line of cumulus. North of that we see the unstable cloud streets, and then south of it, and then this arc right here, we have this more subsident air mass, drier air mass, where no thunderstorms are developing. And then southwest of the storm, we see that it's pretty much cleared out. And what's happening is that's a good indicator that this storm is intensifying. So we have a few different indicators that the storm is intensifying. First, we have a rather large area of overshooting tops, pretty robust, and then also hard edge to the anvil cirrus right here. We have southwesterly flow aloft, so it's this up shear growth of the anvil cirrus right here is a good sign that we have this thunderstorm intensifying quite a bit, because it has a very sharp edge to it right here. And then meanwhile, on the southwest flank of the storm, we have this clear region that has developed, and that's due to the compensating subsidence in the vicinity of a strong updraft. So our updraft's right here. The downdraft, or the subsident area, tends to be up shear of it, in this case to the southwest flank of it. So those clouds that we saw earlier have now dissipated in this area here. So we have this clear region in here. Meanwhile, we have this inflow region coming into the storm like so here. So we have numerous indicators here of a intensifying thunderstorm. So let's go ahead and advance our loop here just to see what happens with this particular thunderstorm. I'm going to focus on the early portion of it here first, and see that remember earlier we had kind of a series of different updrafts, few different updrafts, and maybe some smaller storms. But then by the time we get to the beginning of this loop, we really have one updraft, one dominant storm here. And again, that's another sign of an intensifying storm. We can go ahead and confirm that with the radar imagery. So here's the half-degree reflectivity from the Denver radar, which is located right here. Notice early in the loop, right here, this is at 2028, here's the dominant storm over Evergreen at this time. However, you see a few different storms out ahead of it. Right here, and right here. And then as we transition in time here, intensification of this updraft really took place, and then these other storms here either go away or they pretty much merge with that updraft. And also notice on the southwest flank of that storm here, the smaller storms pretty much go away, so that by the time we get to the end of the loop here, we're left with pretty much one dominant storm because of all that intensification that has taken place. Next, I'm going to show you in the visible imagery some satellite signatures that are important, but first I just want to simplify things with a schematic. So here's a schematic. Here's our overshooting top, the above anvil cirrus, and then the edge of the cirrus right here. So this is your supercell diagram as you might see it from satellite imagery. Here's the flanking line, and then the dividing line between the flanking line on the inflow side of the storm. This is something we may see, and in fact we do see it with this particular storm, so I'll point it out. These are inflow feeder clouds which form within converging inflow near the strongest updraft. When you see these, the storm is undergoing intensification and severe weather is likely pretty soon after this. Some studies have been done on this. You can see the reference on the blog entry on the web page in terms of the correlation of this with severe weather reports. So if you want more information, you can see the reference on the student guide that pertains to these features here. And then west of the flanking line, up shear of the main updraft here. This is another thing that you may see, these lines of towering cumulus that form above an invigorated rear flank downdraft, this RFD. And this is more of an open topic for research. Not sure the mechanism of what causes these, but we know when we see these, the storm tends to be in a mature phase or a rapidly intensifying phase, and again, a pretty good correlation with severe weather. Just because you don't see these signatures does not mean the storm is not severe, but when you do see these, think of it as an added bonus, much like the enhanced V signature. You can have an appreciation that these storms are most likely severe or going through a rapid intensification phase. So let's go back to our visible loop and zoom in on the Denver storm, and we're going to analyze these features here. So let's go to this time period where we begin to see some clouds developing around the storm here. So here's our flanking line right here. Here we see invigorated cumulus that develops above the RFD. So these are not moving into the storm. They're developing above the RFD here. And then meanwhile over here we have our inflow feeder clouds. And I'm just circling these here because they really show up best in the loop. To get your attention, I want to show you where these are and then go ahead and let the loop run here. So again, east of the flanking line, you can easily see the inflow nature of these storms here, which corresponds to their name, inflow feeder cloud. So you can see these feeding into the storm here. What's happening is they're converging, and then as they're getting closer and closer to the updraft, you see these more vertical development to the cumulus as they feed into the storm. And then on the southwest and western flank, you see these towering cumulus that form above an invigorated RFD, and then later in the loop you can see that they pretty much go away here. The other thing you can see here, very noticeable, is divergence at storm top level, and if you walk through this slowly, you can probably convince yourself here that you have storm top rotation occurring here with this storm as well. You can see indications of outflow on the back side of the storm near the front range. That I'll just draw a line back here. And then finally here, what we're going to look at next here is some hail on the ground. So I'm going to go to the time of interest because it's quite subtle, so I need to point this out and then go back to the loop so you can see this. And I'll go ahead and stop it right here. And note this region right in here. If I go back and forth, we can see that that region does not move. So it's most likely not indicative of a cloud because it's not moving at all. And if we go back to our animation here, I'll leave my annotation on there. Notice that it was not there before the storm. So we have this region of lighter colors here. Those are more reflective in terms of what we're looking at in the visible imagery here. And what we're looking at is hail that's left behind the storm. The storm put down a lot of hail. Let's go ahead to our photo here. This was right behind the storm, and you can see a lot of hail over a fairly large area here. So if we go back to our visible loop here, zoom in, That's actually a hail swath that is left in the wake of the storm. And it shows up because in SRSO you have 1 minute imagery. You're seeing this in enough images to catch your attention here. So you see it in more than just one image. You're getting more than just a flash look at this here. So it's rather interesting that it shows up in the imagery here because it covered a large enough area of sufficient depth, and obviously it played a role here. It had to call out the snowplows to get the hail off the road because it can be a hazard to drive in. Okay, let's go on to our next loop, which is right here. Zoom in on the Denver storm. And what do we see with the Denver storm? We continue to see a lot of divergence at storm top level. And again, you can convince yourself that you have rotation there at storm top as well. We have other storms coming in from the south, and their anvil cirrus kind of comes in and obscures what's going on with our storm here. But before that happens, you can continue to see those inflow feeder clouds feeding into the storm here. Eventually, this storm would merge with some other storms that were developing further to the south and east. If we shift our attention up here to southeast Wyoming, we see an interesting transition that has taken place. I'll go ahead and stop it about midway through the loop here. Go ahead and stop it right here. And notice that you can see our stable wave clouds in this general vicinity extending out into Nebraska, and here's Wyoming right here. South of that, we can now have our unstable cloud streets parallel to the boundary layer flow here, so they're north to south oriented. And then, of course, where these two regions are intersecting, we would have a boundary which would be oriented approximately right in here. On the Denver storm, what if we had RSO imagery in AWIPS that was available? So this is what you would see if you were looking at this in real time. This is the normal, so to speak, rapid scan operations where you get 8 images per hour. And of course, this is an AWIPS, so it's remapped. The imagery that we were looking at before, displayed in McItis, is not remapped in any way. It's in the native projection. So this is the remap data in AWIPS. And the question you would ask yourself here is, what would you have seen in the RSO loop? Is this is all that you had available? Would you have been able to see these? And the short answer is yes on most of the features that we talked about. However, it just shows up a lot easier when you have more images to look at. For example, the hail swath that we looked at, you can see it. It's right in here. But would that have caught your attention? It's quite subtle, especially when you have only a few images to look at. Other clouds are coming in rather quickly, and I would argue it's very subtle in this imagery to look at that. The inflow feeder clouds that we were looking at on the east side of the storm, you can still see them, but you just don't get that feeling of these moving into the storms quite as much because we don't have as many images to work with here. The invigorated cumulus on the back side of the storm that formed above the RFD. Again, you see them, but they kind of come and go really fast, so they don't give you an appreciation of what's happening at the storm scale level with these when you have the fewer images. So again, when you have more images to look at here, it just catches your eyes, your attention that much more easily. And also, we're looking at this in a remapped sense. So these are looking a little bit more distorted than they were in the unremapped McItis imagery here. So those are the advantages of looking at this SRSO imagery, this 1 minute imagery here. Let's go back and shift our attention to the north here in Wyoming. And remember, we just analyzed this boundary that was oriented approximately like so, where we have stable wave clouds to the north, unstable cloud streets to the south. And a couple things to notice here. First of all, you have this region where you see towering cumulus develop into what looks like small storm by the end of the loop. And it also looks like multiple updrafts. If you just look in this region here, still have a few different updrafts, so you have maybe multiple small storms developing along that boundary. And then over here further to the west, along the higher terrain still, we have a thunderstorm that's moving towards the northeast. It's not rapidly intensifying, but you see pulsing updrafts associated with that. And the obvious question here is what will happen with these storms, particularly with storm motion towards the northeast. Remember, we have southwest flow aloft. So any storm that moves towards the stable air mass here will meet the fate of something similar to this storm that I'm circling to the north. So it moves off the higher terrain towards that region that's more stable, and you can see it quickly dies off. So the question is, what will happen with these storms? Can they stay along this boundary, or do they move to the northeast and meet a quick demise? Here's the visible loop. Let's go ahead and zoom in. And first notice the complex of storms furthest to the east. Remember, they were a series of small storms, and you can see those moved off to the northeast. So what happened is they met a quick demise. They moved into that more stable air mass, the region where we had been analyzing the stable wave clouds, so they quickly weakened. However, this storm over here that was moving off the mountains was initially moving towards the northeast, but notice it's really slowed down now. It almost looks like it's stationary. It's moving just a little bit. But the other thing to note is it's pretty rapidly intensifying compared to what we were looking at earlier. It had that pulsing updraft nature to it. Now you get a more robust looking updraft. You see overshooting tops at the top of the storm. You see quite a bit more anvil cirrus coming out, another good sign of the storm intensifying. But most importantly, maybe it's not moving quickly to the northeast like the other storms here. So it's not moving towards that more stable air mass. What it's probably doing is it's latching onto that boundary, that convergence boundary that we had been analyzing here. Perhaps it's also interacted with outflow from these earlier small storms. That's another potential thing that may be going on here. But we know we have that boundary. We've been analyzing it for a while now. And this particular storm seems to be intensifying along that boundary. So that's something that would definitely heighten your situational awareness here. Let's go ahead and look at what's happening to the storm to the northwest here as well. You can see this other storm to the northwest over higher terrain, but you can see signs of rapid intensification here as well. You see overshooting top. You see this above anvil cirrus really spreading out quickly here, and the storm went through quite an intensification phase here around that time period. And it's important to note this storm is pretty far from the radar, so it's good to have that imagery here to look at and look at some of these trends here. Whenever you have a storm that's far from the radar, this is where SRSO can really help you out here. So let's go ahead and see how did these look in the radar reflectivity. Here's the radar down here at Cheyenne. Here's our first storm of interest. Remember, we saw these storms furthest to the east, these smaller storms, move to the northeast and kind of quickly die off. Now you can see a couple of those kind of merged over here with this other storm, which is interesting as well. This particular storm right here, this is the one that had been moving northeast off the mountains. Looks like it interacted with that east to west boundary, really intensified, as you can see in the reflectivity here as well, and just really slowed down. So it didn't have that northeastward movement as much as it did earlier, so it's interacting with that boundary. And at 1:15 UTC, there was a tornado associated with this particular storm. You can see a picture of it on the blog entry on the web there, just a link to it, so you can see the tornado associated with that. And meanwhile, here's that other storm that is going through quite a bit of intensification as it's over that higher terrain just southwest of Douglas. And notice, like I said earlier, it's pretty far from the radar here, so having that SRSO imagery helps you out here. And whenever you have these storms further from the radar, you can assess trends here in terms of what's happening with the storm. So that concludes this blog entry here, and this is again something to look forward to when GOES-R comes along, and we'll have not only 1 minute of imagery available, but also up to 30-second temporal resolution available. So very high temporal resolution. These are the kind of things you can do in terms of analysis with this very high temporal resolution satellite data that will be available with GOES-R.